Hi, my name is Varsha. I'm pursuing my bachelor's in Electronics and Communication Engineering at Cambridge Institute of Technology, Bangalore. I'm doing an internship at Emertxe, and my project is a washing machine simulation. Here in this presentation, I'll be discussing about it. C programming. C programming is used in system software development, embedded software development, OS kernel development, firmware, middleware, and driver development, file system development, and many more. C is used effectively in various specific domains, and it is free formatted language and efficiency and portability. Number systems in C programming like decimal, octal, and hexadecimal and binary can be used. Data representation is in the form of bit, byte, and word. Integrated number is positive and negative. So then data type integral can be character, integer, and in floating point is float and double. So in conditional constructs, we have three: single iteration, multiple iteration, and unconditional. Under single iteration, we have if else if, and switch cases. Under multiple iterations, we have while, do while, and for loops. Under unconditional, we have continue and break. So in embedded C, embedded C is an updated version of C. We use embedded C for hardware devices. So in embedded C, we'll be learning about operators, arrays, pointers, function, and strings. Under operators, operators are that operates on its operands and which have no return type. Then array is a collection of data type of similar, array is a collection of data of a similar data type. So the addresses are sequential. And next we comes for the pointer. Pointer is a pointer which holds the value or which holds the address of another pointer. Um, then the parameter passing mechanism in function, by passing the reference, we can use pointers. Then the function we have pass by value and pass by reference, which is used to perform a specific task, and return more than one value from a function. It can be by through passing an array, returning an array, and recursive. Next, strings. Strings is the contiguous sequence of characters, easily stores ASCII and its extensions. Now we have microcontroller. So it is an integrated circuit which is capable of being programmed to perform a specific task. So when we are choosing a microcontroller for any of our project, we have to note all these following points. That is application, performance, price, availability of tools, and special capabilities. Then the advantages includes all the components comes in a single chip, which is handy, and it is less flexible and less design complexity. And then it is microprocessor. A microprocessor is a computer processor wherein the data processing logic and control is included on a single integrated circuit, which makes more handy. And you don't need external devices or equipments to handle it. So, or a small number of integrated circuits. The advantages are all separate components, and it is more flexible. And the disadvantage is more design complexity. Next, the embedded system. So embedded system plays an important role in designing a hardware component or a product. So the any embedded system can be defined as any combination of hardware and software which is intended to do a specific task can be called as an embedded system. Then under these categories are standalone, real-time, network, and mobile. Challenges faced in embedded system is efficient in input and output, embedded in operating system, then code optimization, testing, and debugging. So the real-time aspects are hard real-time, firm real-time, and soft real-time. So the hard real-time is that should meet its deadline. That is a life-critical application which needs an immediate response. Firm real-time is similar to that of hard real-time, and then the soft real-time can have tolerance in meeting its deadlines. That is, even if the deadline is met, it will have some concession. So now for this project, I have used few software for developing my product. Then some of the softwares are Lab XIDE, Picsimlab, and for compilation of the code, I've used X8 compiler. So Lab XIDE, so it is an expandable, highly configurable software program that incorporates powerful tools to help you discover, configure, develop, debug, and qualify embedded design for most of our microcontroller and digital signal controllers. MPLAB supports project management, editing, debugging, and programming of microchip 8-bit, 16-bit, and 32-bit PIC microcontrollers. Then we have used Picsimlab. So it is an real-time emulate of development boards with integrated MPLabX for coding, for code editing and debugging. The same tools is used for the real-time board also. So then we have X8 compiler. X8 compiler is a C compiler from Microchip for 8-bit PICs, which runs both on Windows, Mac OS, and Linux. So here I have taken an interface of LED. We all know that LED is the simplest device which is used in most of the embedded applications as a feedback. It just works like a diode. So in this we have done a basic program demo, use toggling of LED using port B, that is PIC 16F877A, and that is the code is developed in MPLAB XID software, and that is converted into hex file, and that it is loaded in the Picsimlab software. Which I'll be showing in the further things. Then the board we have used is Pic Genius board, and the microcontroller is PIC 16F877A. So as I told in the previous slide, this is the board which have included the snapshot from my project. Then this is the PIC 16F877A board, and this is the CLCD display, which we can display any kind of messages. This is the fan or the DC motor. And here is a buzzer. These are the displays, and here we have keys, and these 6 are the digital keypad keys, and these are the LEDs. And we have see, this is the microcontroller PIC 16F877A microcontroller, and we have a reset pin. And yeah, so next, as I told in the previous slide, that this is the CLCD display. So CLCD is defined as character liquid crystal display. It is of two types, that is 16x2 and 16x4. Used to display all ASCII characters and symbols. D0 to D7 are the data transfer line that controller can execute the instructions and data. RS is the register select line. If RS value is 1, that means data is executed. If RS value is 0, that means instruction is executed. Then we have tackle switches. So these are the tackle switches. We have in the matrix keypad, we need to configure rows as outputs and columns as inputs. When designing the pull down interface, we have to design in such a way that R1 is greater than, sorry, R1 is 10 times greater than R2. So the triggering methods can be edge triggered or level triggered. Uh, then we have bouncing effect. There is a metal plate and a terminal in the tackle switches. That is spurious pulse detection while pressing or releasing the tackle switches. That is called as a bouncing effect. So then we have timers. We have three modes in it, like PWM, counter, and PP measurement. Then these are the terminologies that are tick, quantum, scaling, and resolution. Tick can be of up count or down count. Quantum is a system clock setting. Scaling also can be of pre or post. Then we have resolution register width. Now we'll be seeing the washing machine simulation using Picsimlab software. So as I showed the board, this is the PIC16F 877A board, and here we'll be loading an hex file using this file option. We'll be loading an hex file which we have coded in MPLab XID software. That code is dumped onto the board. Then when the code is dumped on the board, we get the message like press key 5 to power on the washing machine. So here we have key 1, 2, 3, 4, and 5. So we'll have to press this key 5 to power on the washing machine. Then we get a display message as powering on the washing machine, which means that washing machine is an on mode. Then then we'll have to select the washing programs. That is the what kind of wash we need to select. Is like we have I have included daily, heavy, delicates, then whites, stain wash things, and stain wash, eco cottons, and woolen. Then we'll have to select the water level by long pressing this key 3, sorry, key 4. And the water level can be set like auto, low, medium, high. Then we get this display like press switch 5 to start and switch 6 to stop. So this is switch 5 to start and switch 6 to stop. So when we are ready to start the operation, we can press the switch 5 to, which means that's the start of the wash. So for every kind of cloth, the timer is set, and that kind of timer starts. And in this program I have given in minutes and seconds. So here in this snapshots for the program I have chosen as woolen. So for the woolen, the 30-second I have set to 30-second, and the wash is going on, which will be indicated by this fan, which starts running. So there are the functions like wash, rinse, and spin. These functions go on level by level. And here we also get the options like switch, press 5 to start, and press 6 to pause. So if we press this key 6, that means the wash is paused, and then we get a buzzer sound. So we get a buzzer sound, like if the door is open, we get a buzzer sound that can be checked using this key 1. So if we press the key 1, it means that the door is open and we get the buzzer sound. So then if all the process like wash, rinse, and spin is completed, we get the message as program completed, and you can remove the clothes. So this is the oral explanation of my project. Now I'll be showing the demo on how my project works. So now let's see how the actual working is. So here is the code where I have interface, digital keypad, and CLCD and other things, switches, tackle switches, and other things. So I'll be navigating it to the Picsimlab software.
So this is the software, and here I have loaded the code and I get press key 5 to power on the washing machine. Now I have pressed powering on washing machine. Here are the washing programs like daily, delicates, heavy. Here I'll be selecting the washing program by long pressing the key 4. So now here I am selecting whites. So then I'll have to select the water level, that is auto, level and medium. So now here I'll be selecting medium. So after the water level is set, so we get press switch 5 to start and switch 6 to stop. I have started the process. So wash is going on. So if in case the door is open, which will be pressing the key 1, we get a buzzer sound. Now the process continues. We can keep checking like this. If the door is open, you get an alert message. So now the function, I have choose whites and the function wash is going on. So I can press 5 to start and 6 to pause. So if I press the 6, switch 6, it pauses the process. Now the function wash is going on, which also be indicated by fan which is running. And now the rinse function is going on. Now the function is spin. So the time was set to about 1 to 120 seconds, 1 minute 20 seconds. So after the process is completed, you get a message, and which also is added with an additional buzzer sound, which indicates the program is completed, and you can remove your clothes. So yeah, now the program is completed. We can remove our clothes.